Okay, this purple region over here is the area bounded by 3 plus the secant of x from negative pi over 3 to pi over 3, and the line y equals 5. We're supposed to revolve that purple region about the line y equals 3, which is this green dotted line here. So we're going to use a volume by the washer method, and that's outer radius. It's the integral from pi times the integral from a to b, in our case from negative pi over 3 to pi over 3, of outer radius squared minus inner radius squared. How do we calculate the outer radius? The outer radius is the distance from the axis of revolution to the farthest most part of the region that we're revolving. The y-coordinate of any point along this line is 5. The y-coordinate of any point along the axis of revolution is 3. To get the distance from 3 to 5, we subtract. 5 minus 3 is 2. Top minus bottom is actually the length of this rectangle right here. To get the inner radius, which is this distance right here, we want the y-coordinate at the top minus the y-coordinate at the bottom. Because see, if we pictured the x-axis down here somewhere, this distance right here would be 3 plus the secant of x. And then if we take away this distance, we've got the length of the inner radius. So usually we just think y at the top minus y at the bottom. So there's y at the top minus y at the bottom. That gives us just the secant of x. So our formula is pi times the definite integral from negative pi over 3 to pi over 3. In other words, these washers are piling up along perpendicular to the axis of revolution. And then the outer radius squared minus the inner radius squared. 2 squared is 4. Secant squared is secant squared. And if we wanted to, we could realize that this purple region is symmetric about the y-axis. So we could just say, hey, you know what? I'm going to just go from 0 to pi over 3 and double it. So that's what we're going to evaluate right there. Now, how do we do that? Well, we need an antiderivative of this, which would be 4x for the first term. The antiderivative of secant squared is tangent. We want to evaluate that from 0 to pi over 3. And whatever that turns out to be, we want to multiply that by 2 pi. Okay, and here we have it evaluated on board 2. There's the antiderivative from 0 to pi over 3. If we put pi over 3 in for this x, we get 4 pi over 3. If we put pi over 3 in for this x, what's the tangent of pi over 3? Well, it's the same as the tangent of 60 degrees, which is radical 3 over 1, so radical 3. And then if we put 0 in for x, we get 0 minus, because the tangent of 0 is 0. And if we want to, we can distribute this 2 pi times each term inside the parentheses. 8 pi squared over 3 minus 2 pi over 3. And here's some proof on Desmos that apparently those equate to the same value. So there you go. Hope that helped. And if you have any questions, post a comment.